Spanning tree RootGuard is a security-related spanning tree enhancement from Cisco. The purpose of this feature is to protect our switch topology from the rogue root switches. The rogue root switches are the switches that are sending superior BPDUs, and the definition of the superior BPDU can be many things. One, it's a BPDU that has the lower priority or the MAC address than the current root. Or it's a BPDU that is coming from the same root but is being received on the designated port of the local switch, and it claims to have a better root path cost than our own port. When the RootGuard is enabled on the port, it is enabled for all the VLANs, and this is the only way to configure the RootGuard. It can be enabled only on per port basis for all the VLANs on that port. When a superior BPDU is received on a port with the RootGuard enabled, what is going to happen is that this port is going to be moved into a spanning tree root inconsistent state. This is a special state that doesn't exist in the standard definition of the spanning tree, and in this state the local port will still be sending the local BPDUs, but all the traffic coming in on that port and all the BPDUs received on that port are going to be ignored if they are superior to our own local copy of the best BPDU. This state can be easily cleared from the port if we simply stop receiving the superior BPDUs from another switch. Let me give you an example of all this. Let's imagine a network consisting of 3 switches: our Cat1, Cat2, and Cat3. Let's say that Cat1 and Cat2 are the core switches in our network, and they have a high-speed interconnection of 1 gigabit per second. So this is gigabit 01 and this is gigabit 01. Now let's say that Cat3 here is either an access switch or it may be a distribution switch. But let's keep it simple. Let's say that it is an access switch, and it has dual uplinks to both Cat1 and Cat2, but these uplinks are a little bit slower. So these are going to be the fast Ethernet links. So this is going to be fast Ethernet 22, and this is going to be fast Ethernet 22 here. This is fast Ethernet 20, and this is fast Ethernet 20. In this network here, let's say that the majority of hosts are behind Cat1 and Cat2. So these are some hosts here and some hosts here, large number of these hosts here. And let's say that behind Cat3, I just have a few hosts. In this network as it is, the preferred topology is to have a gigabit link here in a forwarding state and one of 2 links between Cat3 and Cat1 or Cat2 forwarding and the other one blocking. So let's say that this is the topology that we want to have. If we want this topology here, we need to ensure that Cat1 is the root, we need to ensure that Cat2 here is the secondary root or the backup root for Cat1, and we need to ensure that Cat3 is the least likely to become the root. But what would happen in this network if Cat3 would be configured to be the root, if it simply claims to be the root? Well, what will happen is it will start sending superior BPDUs. It will send the superior BPDU to Cat1, it would send the superior BPDU to Cat2, even though this port here is blocking. The BPDUs received from Cat1 sent to Cat2 and then from Cat2 to Cat3 are going to be inferior to our own local copy, which means that Cat3 is going to determine that it has won the root election, and it's going to simply start sending its own copy of the BPDU towards Cat2, even though this was a blocking port in the original topology. When this happens, Cat2 here is going to determine that it needs to recalculate its spanning tree. The same thing is going to happen on Cat1. So if Cat3 claims to be the root, the resulting spanning tree topology is going to look like this. So I'm going to have Cat1, Cat2, Cat3. Remember, this here is the gigabit link, this here is the fast Ethernet link, and this here is the fast Ethernet link. But the actual active topology is going to be like this. And what's going to happen most likely is that this becomes the designated port and this becomes the blocking port. And given the fact that vast majority of hosts are sitting behind Cat1 and Cat2, we can no longer use the high-speed link between them, and instead we actually need to send the traffic over the slow links between Cat1, Cat3, and Cat3 and Cat2. This is clearly an undesirable situation, but in traditional spanning tree, there is really nothing we can do about this, because there is no authentication in the spanning tree, there is no encryption, there is no protection of any sorts. And this is pretty much the situation that RootGuard was designed to solve. So how can we use the RootGuard to solve this particular problem? Let's take a look. I'm going to start by redrawing the network diagram. So I have Cat1, I have Cat2, and I have Cat3. This link here between Cat1 and Cat2 is the link that I want to have operational for most of the time. And this link here is preferred to be operational. The link between Cat2 and Cat3 is the link that I don't really care about that much. So I'm just going to draw it like this. The good candidate for the RootGuard is this interface here, the fast Ethernet 20 on Cat2. If I enable the RootGuard on this interface here, and if Cat3 claims to be the root, and I'm going to call it the rogue root, and it starts sending its own BPDU here, Cat2 will detect that this BPDU is claiming to be the superior one in comparison to the one coming from Cat1. When this happens, what Cat2 is going to do, it's going to put this port here into a root inconsistent state. Let's take a look at this in action. Before I jump into the terminal to configure this, just a quick reminder that this here is fast Ethernet 22, and this here is fast Ethernet 20. So now I'm going to go to my terminal and let's see the configuration. If I do show spanning tree on Cat1, I can see that this is the configuration. Cat1 is the root and this is the priority on Cat1. It's the default priority. I can see two interfaces, Gigabit 01 and Fast Ethernet 22. They are both designated and forwarding as is expected on the root switch. On Cat2, if I do show spanning tree, I can see that the bridge priority on this switch is 53,248 plus 1, and just a correction here on Cat1, this was actually the configuration of the Cat1, but it's also the root. This is why I was showing you the upper part of this output, because I simply looked at this line here telling me it's the root, and then I just explained using this line. But on Cat2 we actually have to look at this, because this is the local configuration. And I can see that this switch here has the priority that is higher than the one from Cat1. So this is not going to be the root. Also, I can see that Gigabit 01 is a root port and is in forwarding state, and Fast Ethernet 20 is the designated port and is also forwarding. On Cat3, if I do show spanning tree, I will see that this switch here has the priority, which is the default, but let's make it less likely to become the root. So I'm just going to say spanning tree VLAN 161.440, actually priority 61440. So now if I do show spanning tree, I will see that this bridge now, this switch is going to be the least likely to become the root in our network because it has the highest priority. Also, I can see the two interfaces here, Fast Ethernet 20 and Fast Ethernet 22, and as expected, the Fast Ethernet 22, the one facing Cat1, is the root port and is in forwarding state, and Fast Ethernet 20 is in blocking state. So this is how this operates without any changes. So let's now make our cat3 the rogue root. I'm going to go into the configure terminal and I'm going to say spanning tree VLAN 1 priority 0. Cat3 is now claiming to be the root. Let's verify that. If I do show spanning tree, I can see here information that this bridge is the root. If I go to cat2 and I repeat my show spanning tree, I will see now that gigabit 01 is now in blocking state. Effectively, what I have done is I have replicated this particular topology here. So let's try to avoid this. Let's try to do this. Let's enable the RootGuard on cat2 and see if something changes. So I'm going to go back to cat2 now, and I'm going to start by shutting down the port fast Ethernet 20. And on cat3 here, I'm going to undo making it the root. So I'm just going to say spanning tree VLAN 1 priority 61440. Let's see this. It shouldn't be root for much longer, so I can see. Let's see. Cat1, this bridge is the root. Okay, it's just converged here. Cat3. Yes, FastNet 22 is now a root port. Takes time with spanning tree. And now FastNet 20 on Cat2, I'm going to bring it out of shutdown. So what I'm doing with all this configuration is I'm rolling back the change I did just before to make sure that I actually have this situation here, that FastNet 22 is the root port and FastNet 20 is the designated port towards Cat2. On Cat2, if I do show spanning tree, I see now that FastNet 20 is in a learning phase. So let's give it some time to move into the forwarding state. Up to 15 seconds, there we go. So FastNet 20 is now in forwarding state. Now let's configure FastNet 20 on Cat2 with the RootGuard. The configuration to do that is spanning tree guard root. So now the RootGuard is enabled. How can I verify if the RootGuard is enabled? Well, very simple. I'm going to say show spanning tree interface fast Ethernet 20 detail, and in the output here I will see that RootGuard is enabled on this port. Now let's go to Cat3 and make it a rogue root. I'm going to say spanning tree VLAN 1 root primary, or let's just set priority manually. So I'm just going to say spanning tree VLAN 1 priority 0. Now Cat3 is again claiming to be the root, but take a look what happened on Cat2. Cat2 now said, well, we have a problem with this approach. The RootGuard is now blocking the port fast Ethernet 20. It is doing what it's designed to do. And if I do show spanning tree, in the output here, this is what I'm going to see if my port is blocking. Now, depending on how many ports you have, it may be actually rather difficult to use this command to find out all the ports that may be in an inconsistent state. Luckily, there is a command called show spanning tree inconsistent ports. That's a mouthful, but when we run this command, the only thing that we are going to get is which interfaces in which VLAN are actually in inconsistent state and are being blocking for which reason. Now, root inconsistency is just one of the reasons that the port can be blocking in this way. There are other features that may trigger the blocking of ports in a similar way, but I'm going to talk about them in one of the later videos. So now Cat2 actually protected our infrastructure from the rogue root. If I do show spanning tree, I will see that my gigabit 01 is still operational. But there is a problem with this approach in this particular topology. So let's redraw our topology again. I have cat1, cat2, and cat3. They are interconnected as such. So this is gigabit 01, this is fast Ethernet 22, and this is fast Ethernet 20. This is root, which means that this port here is the designated port, this is the designated port, this is the root port, this will be the root port, this will be the designated port, and this port here will be blocking. Now, let's say that cat3 is not claiming to be the rogue root. It's simply an innocent access switch. The next thing that happens is this link here fails. When this link fails and after the max age expires, what's going to happen is that cat3 is going to start sending BPDUs that it originally received from cat1. When this BPDU is received on this port here, it is going to cause cat2 to put this port in a root inconsistent state. Why? When this link failed between cat1 and cat2, because this port here was blocking, it wasn't sending any BPDUs, which means that cat2 declared itself as a root. But remember, if this link was operational between cat1 and cat2, cat1 would be the root, which means that cat1's BPDUs are superior to those from cat2. Now, when this block moves out of the blocking state, these superior BPDUs are going to be received on the port that has a RootGuard enabled. When this happens, this port here is going to be moved into an inconsistent state. Effectively, what cat2 did with this configuration is to completely cut itself off both cat1 and cat2. Again, let me show you this. I have undone the changes from the previous example. So what I have now on cat1, if I do show spanning tree, I will see my two interfaces, gigabit 01 and fast Ethernet 22, in forwarding state, and I can see that both of these ports are designated as expected. On cat2, I see gigabit 01 as root port and fast Ethernet 20 as the designated port. Remember, this is the port facing cat3. Cat3, our access switch, shows me that fast Ethernet 20, the port facing cat2, is in alternate blocking state, and fast Ethernet 20 is the root port in forwarding state. Now, let's see what happens. Actually, before I do that, if I do on cat2, show spanning tree, interface fast Ethernet 20, detail, I see that RootGuard is enabled on the port facing cat3. So this is the situation that we have now. The link between cat1 and cat2 fails. So the link is now gone. What is happening now is cat2 is no longer sending BPDU frames to cat3 on port fast Ethernet 22, which means that slowly but surely the max age timer is counting down on cat3. When this happens, the port fast Ethernet 20, this one here, is going to start sending BPDU frames towards cat2. What happened on cat2 now? Take a look. RootGuard started blocking port fast Ethernet 20 on VLAN 1. If I do show spanning tree, this is what I see. I have only one port and is actually in a root inconsistent state. So how do I recover from this? Well, the simplest solution would be, of course, to turn off the RootGuard on this port. But let's say that before I had the opportunity to do that, the link between cat1 and cat2 actually recovered. So what I'm going to do now is I'm going to bring this interface up. So what this is going to do is it's going to cause gigabit 01 to move into a listening phase. When this happens, gigabit 01 is going to become a root port. On Cat3, if I take a look at the show spanning tree, now I can see that port fast Ethernet 20, the one facing Cat2, is actually now moved, is now in the blocking state. When the port is in a blocking state, it no longer sends the BPDUs, which means that Cat2 is now no longer receiving superior BPDUs, which we can see from this error message here. Or actually not this error message, this is a log message. This is a good message because now I'm told that the RootGuard has unblocked the fast Ethernet 20 in VLAN 1. If I do show spanning tree, I will see now that everything looks fine on Cat2.